499. No. When Branson gets back. The measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measures of the intercepted arcs. I don't think so. Nick, I want you paying attention. So we have a circle. We're going to have two chords that intersect inside the circle. And we are interested in what is the measure of that angle. And we have arcs A, B, and arc CD are given as the diagram. And what we want to prove is that angle 1 is half the sum of the intercepted arcs. How can I tell which arcs it's talking about when it says the intercepted arcs? Angle 1 seems to intercept this arc. What other arc is it talking about, though? These, yes, the CD arc. These vertical angles are congruent, so the intercepted arcs are the arcs intercepted by angle 1 and its vertical angle. So we are also talking about this CD arc. So I'm proving that the measure of angle 1 is 1/2 the sum of the intercepted arcs. Now the reason why this works is because if I draw this auxiliary line from A to D, I am going to have two inscribed angles formed by that one chord. The inscribed angles, angles 2 and 3, are each half of their intercepted arc. Measure of angle 2 is half of AB. By theorem 9-7, the inscribed angle is 1/2 the intercepted arc. So 2 is half of arc AB. And 3 is half of what arc? No, it's an inscribed angle. Take a look at angle 3 and think inscribed angle, what arc is inside angle 3? Oh, CD. So measure of angle 3 is 1/2 the measure of arc CD. Now, if you look at this triangle, here's the triangle we're working with. Kira, you need to be taking notes or focused up here or something. Okay? So, when we look at this triangle, yes, I know I have a green triangle as well as an extended line. But what you see is that angle 1 is an exterior angle to the triangle that has angles 2 and 3. What do you know about an exterior angle of a triangle? Yes, Measure of angle 1 is the sum of the two remote interior angles, sum of 2 and 3. That is by theorem 312, which is your exterior angle theorem. The measure of angle 1 is equal to the measures of angle 2 plus angle 3. Now when we do a substitution, angle 2 is half of AB and angle 3 is half of CD. We know then that this is equal to 1/2 the sum of these arcs when we factor out that 1/2. So 1/2 arc AB plus arc CD. Theorem 910 now. Because Theorem 910 has 3 cases, there are 3 proofs, so to speak, with Theorem 910. So Theorem 910 says if you have an angle formed by 2 secants, by a secant and a tangent, or by 2 tangents, that's where your 3 cases come from, then it's equal to 1/2 the difference of the 2 intercepted arcs.
Failing when part A comes to the opposite.
So if an angle outside a circle is formed by 2 secants, two tangents, I'll do it that order, or by a secant and a tangent, then it will be 1/2 the difference of the 2 intercepted arcs. Tommy and Nick. Okay, so now pay attention here. So now, we're going to have 3 cases. That means I need 3 diagrams. First off, 2 secants. Here is the angle formed by 2 secants. I'm calling it angle 1, even though I'll move it this way so you can actually see it as a number. 2 tangents. Here is an angle formed by 2 tangents, if I can manage this. Thank you, thank you. Now, a secant and a tangent, and I have to shrink these a little bit, so I have room. Secant and a tangent. Now, on this diagram, on all of these, what we are given is the diagram basically. Okay? So on this diagram, what I want to prove, labeling my intersection points, is that measure of angle 1 is 1/2 the difference of the two intercepted arcs. What are the two intercepted arcs? If you look at angle 1, what are the two arcs that are inside angle 1? Yes. So 1/2 measure of, and you take your larger arc minus your smaller arc. Measure of AD minus measure of BC. Now, on this one, labeling, here is A, O, B, and measure of angle 1. The question would be, what are the two arcs that are inside this angle? What are the two arcs that are inside this angle? Oh, there are two arcs inside that angle. One of them is arc AB. Yes, Mark. And arc AOB. That whole thing is the other arc. Yes. The other one is arc AOB. Oh. You could call it a D, whatever you want to in your notes. So here, what I want to prove is that the measure of angle 1 is 1/2, again, the difference of these two arcs. And we have to take that larger arc, Branson and Dustin, minus the smaller arc. Larger arc minus the smaller arc. So 1/2 measure of arc AOB minus measure of arc AB. Now our last one. We have two arcs inside this angle as well. This point of tangency is what separates the two arcs. So we're going to have a point here called A, B, and C.
It's A, B, and B, C.
Exactly. Measure of angle 1 is 1/2 the difference of the two arcs. Okay, so our goal is to do these three proofs now. Each case, what we have is either an inscribed angle that we draw an auxiliary line to hit, or an angle formed by a chord and tangent that we're working with. And each time, we're going to end up with the exterior angle of a triangle. So, thinking about what auxiliary line in this first diagram, and what I'm going to do is I'm going to draw the segment from B to D. When I draw that segment, I'm actually forming, if I can draw it so it actually connects those points, I'm actually forming two inscribed angles. The inscribed angles we're working with are angles, we'll call them 2 and 3. And which of those angles is an exterior angle of a triangle? Do you see a triangle and an exterior angle? Branson, you're not paying attention. 2 is the exterior angle of triangle BDC, isn't it? So by theorem 312 then, I know that angle 2 is the sum of 3 and 1. Since I'm wanting to solve for angle 1, notice measure of angle 1 equals something. I'm going to subtract angle 3 from both sides, which gives me measure of angle 2 minus measure of angle 3 is equal to measure of angle 1. Now, if you look at angle 2, by theorem 9.7, what is angle 2? 9.7 says the inscribed angles half the measure of the intercepted arc. Angle 2 intercepts what arc, Branson? Angle 2 is the inscribed angle. What arc does it intercept?
BC.
Here's angle 2, arc AD. So measure of angle 2 is 1/2 of AD. Now look at angle 3. What does angle 3 intercept? Yes. So measure of angle 3 is 1/2 of BC.
That's what you're thinking.
Oh, I get it. I would. And
And now, this is our whole proof, isn't it? Because I want to subtract 2 and 3. 2 is this, 3 is that. Yes, Brenton?
is angle 1 BC or is it
Angle 1 is this angle right here. And what we're proving is that it will equal 1/2 this arc minus that arc. That's what we're proving.
Oh.
Angle 1 will equal 1/2 AD minus BC. Now the reason why is because 2 is an exterior angle, so it's the sum of 1 and 3, which means that 2 minus 3 equals 1. And we know that angle 2 is half of AD, and angle 3 is half of BC. So 1/2 of AD minus 1/2 of BC will equal 2 minus 3, which is angle 1. If you factor out that 1/2, we get what we want to prove right here. Angle 1 is half the difference of those arcs. Now, making room for the next proof. This is somewhat the same here. I need an auxiliary line, and I'm going to draw it so I have a triangle and an exterior angle. The auxiliary line I want is the segment that goes from A to B. We are going to be working with these angles. I called the exterior angle 2 last time. I'll call it 2 again. 2 and 3. Do you see a triangle with an exterior angle there? This is our exterior angle of the green triangle. So 2 is equal to measure of angle 3 plus angle 1, like we had right here. So when we subtract angle 3, we're going to have that measure of angle 1 is equal to measure of angle 2 minus measure of angle 3. Jumping to that point because we've already done those steps. Now, 2 is an angle formed by a chord and a tangent. Theorem 9.10 says something about an angle formed by a chord and a tangent.
That's fair, Jay.
I don't mean 9.10. What do I mean? 9.7, 9.8. Thank you. Look at Theorem 9.8 and read it to me. Branson, Theorem 9.8, what does it say? What does Theorem 9.8 say?
the measure of angle 1 by a chord
Okay. You actually are being too noisy. I want you to be quiet. Okay. Branson just read a theorem to us.
Yeah, what theorem?
And he was reading about, a chord and a tangent. And it said that that angle's half the intercepted arc. So my question for you now is, what is the intercepted arc for angle 2? Because measure of angle 2 is going to be 1/2 of whatever that arc is. What is that intercepted arc for angle 2? For angle 2, inside angle 2, right? Arc ADB or AOB, or however you're reading that point. Do you see how that's inside that angle? Okay, so 1/2 the measure of arc A. Okay, now angle 3 is also an angle formed by Branson and Dustin. Just calling your attention. Thank you, thank you. Angle 3 is an angle formed by a chord and a tangent. What is the arc that's intercepted by angle 3? AB, yes. So measure of angle 3 then is 1/2 of whatever that arc is, AB. Now I'm plugging into this equation here. Angle 2 minus angle 3 is what I have. And I know what angle 2 is, and I know what angle 3 is. So I have the measure of angle 1 then is 1/2, and I'm doing angle 2 first, so that's AOB, minus 1/2 AB, which is angle 3. And that is just plugging into this equation right here. 2 minus 3. And that gives me what I want. Angle 1 is half the difference of those intercepted arcs. Shrinking this so I have room now to do the next proof. Alright, so the next proof here. I again need an auxiliary line that gives me a triangle that has an exterior angle. And I could draw either from C to B or from A to B. I'm going to draw from A to B. And now, my exterior angle, again, I'm going to call 2. My interior angle is 3 and 1. So again, measure of angle 2 is equal to measure of angle 3 plus measure of angle 1. Which means when I subtract angle 3 from both sides, I get measure of angle 1 is measure of angle 2 minus measure of angle 3. We've done this part already, so let's write the fact that measure of angle 1 will equal 2 minus 3. Now again, we're thinking of Theorem 9-7 and 9-8. Theorem 9-7 is going to tell us about the measure of angle 3. And Theorem 9-8 is going to tell us about the measure of angle 2. Now, Dustin, you're up next. Measure of angle 3 is equal to 1/2 what arc?
Measure of angle 3 is 1/2 of 1.
This is Theorem 9-7. Measure of angle 3 is half of what arc? Dustin's the one side.
AB.
Angle 3 has these sides, so the question really is, what arc is inside angle 3?
This
It is CB. Yes.
I did it.
So measure of angle 3, thank you, Branson, is 1/2 measure of arc CB. And I called it BC before, so I'll keep with BC. Okay. So now, yes, Nick is correct. So Branson, you weren't listening. Let me put you on the spot. Angle 2 is half of what arc?
I got this.
No, you're wrong. You can't talk. You can't talk. Brandon's on the spot.
This, the third one, or the second one?
Angle 2 is half of what arc?
A, C.
No. Notice inside angle 2 is what arc?
A.
AB. Yes. So measure of angle 2 is 1/2
So the measure
of AB.
of what?
Now since 1 is 2 minus 3, and we know what 2 and 3 are, then we're going to go 2, which is this one, minus 3, which is that one. So, measure of angle 1, and I'll go to blue since I have on every other last statement here. Measure of angle 1 is going to be 1/2 of AB. And I'm writing in a weird way, so let me try again. Minus, and then 3, which is 1/2 of BC. All right. Now we've done all of that, but let's actually look at application, because this right here is all fine and dandy, but we don't know how to use it yet. So let's find a problem and look at application.
5.
I am looking. Interesting. I really want to do a problem that
I need order to problem.
okay. Here's where I'm at. Page 359. Please turn to page 359. I'm on problem number 11, because that's kind of the easy one. Then we'll do 13. Then we'll move to a different diagram. So number 11. And we have two chords that intersect in a circle. We have RT and US. And on number 11, they tell me that RT is 80. And that US is 40. They want me to find the measure of angle 1. Now, Dustin, what are the intercepted arcs by angle 1?
Is 40.
40 and 80, yes. So measure of angle 1 as an angle formed inside the circle is 1/2 the sum of those angles. So we go 1/2 80 plus 40. So that's 120, which means measure of angle 1 is 60. What's that? Say that again. What it is 1/2 the sum. The sum of those is 120. Okay? Because this is not the center of the circle. The center of the circle may be, let's see if we can find it. Does that look like about the center? Okay? If it's the center of the circle, then you have a central angle. We don't have a central angle here. It's the central angle that's equal to the arc. Right? Okay. Kendra asked a good question. Did all of you understand the answer? Okay. Dustin and Branson, you're not paying attention. Dustin and Branson. Kendra asked a good question. Do you understand the question she asked and the answer? It was, wait, if this is a central angle, then its measure is equal to the arc. Right? Which is 80. No. If it's an inscribed angle, the measure is half of the arc, which is 40. So this angle would be 40. This angle would be 80. But this angle, which is the same as the original angle 1,
Would be 40.
is 60. Because a central angle is equal to the arc. An inscribed angle is half of the arc. Any other random angle inside the circle is 1/2 the sum of the arcs. So moving my central angle off and my inscribed angle off, what we have is an angle that is not a central angle. It's any other angle inside, so you have to go 1/2 the sum of the arcs. Does that make sense to people? Okay. So now, our next problem. I'm going to clone this thing, so I don't have to draw it again. Clone. And
Dump truck.
We're blowing up.
Can we go with the dump truck?
It's like, I don't know if I want to be. Seriously, I want to go look at the dump truck. I won't let a dump truck.
okay, I'm going to stop my recording actually.